In this video, we'll be talking about equivalent resistance. And the idea of equivalent resistance is that you can take several different resistors and wire them all together, with one wire leading out and one wire leading in. And that's equivalent to, in some sense, replacing it by a single circuit. What I mean by it's equivalent to is that I could take that whole section of the circuit out and replace it with a single resistor, and it would function exactly in the same way. It would just have to have a certain specific resistance in order to function in the same way. And equivalent resistance is that specific resistance. Now, the function of a resistor, recall, is to have a current proportional to the voltage drop across it. So it still has that proportionality, but now it just has a different proportionality constant. You end up having similar formulas for equivalent resistance, similar to the equivalent capacitance we had before. But you really want to be careful that these formulas are similar but swapped in a sense. The two basic ways we can combine together two circuit elements is going to be in series or in parallel. And the formula for equivalent resistance when they're in series looks a lot for like equivalent capacitance in the case of parallel capacitors. So if resistors are in series, the resistances just add up together. If you have several of which that are series, you just add all the resistances together. That gives you the equivalent resistance. If they're all in parallel, then you use the reciprocals and you add the reciprocal of the resistances, and that'll equal the reciprocal of the equivalent resistance. And again, the general feature is that when they're in series, the equivalent resistance is bigger than the largest resistance, and when they're set up in parallel, the equivalent resistance will be smaller than the smallest resistor in there. So basically, when you wire them in parallel, this decreases the resistance, whereas if you put them in series, this increases, which matches with our formula for the resistance of a single wire given its resistivity, its length, and its area. If you recall, if you increase the length, which is like hooking up resistors in series, that made the resistance bigger. If you put them in parallel, which is like increasing the area, that would make it smaller. And again, this is because if you add more options, like when you do for in parallel, more options for the current to flow through, it'll make it easier for it to flow through. But if you make it flow through several resistors one after the other, it'll make it harder, so the resistance will go up.